Last lesson, we looked at the measures of central tendency, which was the mean, median, and mode. Today, we're doing some more summary statistics, but we're looking at the spread of scores, which means we're focusing on the range and the interquartile range. Now, the range is a nice simple one. It just measures the difference between the highest and the lowest score in the data. So we have this formula here, range equals highest score minus lowest score. However, because sometimes the highest score might be an outlier or the lowest score might be an outlier, there might be some scores in there that significantly impact on our range but don't really indicate where the majority of scores are, then we have another way of measuring what we call the interquartile range, which measures the range of the middle 50% of the data. So it gets rid of all those extra high and extra low scores. If we want to find the lower quartile, the Q1, we want to do the bottom 25% of the data, and the upper quartile Q3 is showing 3/4 or 75% of the way into the data. And we have a formula for interquartile range, which is Q3 minus Q1. Also, we're going to have to find a 5-point summary. That is these 5 points here, the lowest score, the Q1, the Q2, which is also known as the median, the Q3, and the highest score. And we'll be using those in our next lesson to draw box plots. Now, outliers, if we have outliers in the past, you just look at some scores, and if you have something that's significantly above or significantly below the rest of your scores, you go, that one's probably an outlier. But we want to know for certain. We don't want to be guessing anymore. So we have some formulas that will test to see whether something is an outlier or not. If we sub from the quartiles and the interquartile range that we have found, if we find the Q1 and the interquartile range, Q1 minus 1.5 times the interquartile range will give us a score. If we have any results in our data set that are below that score, then it's going to be an outlier. Likewise, if I find Q3 plus 1.5 times the interquartile range, that will give me a score, and anything above that score is an outlier on the higher side. Okay, we're going to practice that in the examples. So example number 1, find the range of the given data set. So good old-fashioned range is highest score minus the lowest score. So the highest score I have is 9.8, and the lowest score I have is 3.4. That's a range of 6.4. Question 2, calculate the interquartile range of the following set of data. First thing I notice when I look at those scores is that they're not in order. To do interquartile range, I really need them to be so that I can find my middles. So let's go and do that. In order, it will be 1, 2, 3, 3, 5, 6, 6, 7, and 8. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. Even though we don't need the median or the Q2 to find the interquartile range in the formula, we do need to find it first. If there's 9 scores, plus 1 is 10, divided by 2 is 5. So I want the 5th score, 1, 2, 3, 4, 5. That means that the 5 in there is my median. It is the Q2. Because the Q2 is at the score 5, I now no longer am going to use that 5 to find my lower and my upper quartile. So I have 4 scores below that. The middle of those 4 scores would be 2 on either side. When it turns out that one of your quartiles is between 2 numbers, you have to average them to find the quartile. So Q1 is going to be 2 plus 3 divided by 2, which is equal to 2.5. Then I do the same thing for the upper quartile. I have 4 scores above that median. So the middle is going to be 2 on either side. I draw a line in there, and that is where my Q3 is going to be. So I will need to average the scores on either side of that line. 6 plus 7 over 2 makes 6.5. Now I can find my interquartile range, which is the Q3 minus the Q1. Q3 is 6.5, the Q1 is 2.5, so that is equal to 4. Question 3, let's try it again. Consider the data, and I look at the data, it's all in order, which is good. Find the 5-number summary. So it's very similar to what we've just done. We just have the lowest and the highest score in there, and you can do those straight away. The lowest score is going to be 17, and the highest score is going to be 29. Then I want to find my Q1, Q2, Q3, and we always start with the Q2 or the median. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 scores again. So the middle of 9 scores, we go 9 plus 1 all over 2. So that's 10 over 2 is 5 again. 1, 2, 3, 4, 5. There's my 5th score. That number there is my Q2. So 25 for the median. Now because the 25 has been used, there's 4 numbers below that. The middle of those 4 numbers is going to have 2 on either side. So that's 19 and 22 divided by 2, which makes a 20.5 for my Q1. The Q3, again, there's 4 scores up here, so the middle is going to be between 26 and 27.5. So we average them, and that is 26.75. And that's it, that's a 5-number summary. Question 4 says, consider the set of numbers which aren't in order. I'm going to have to find the 5-number summary, the interquartile range, and I need to determine whether or not any outliers exist. So first things first, I need to put my scores in order. So it's 1, 1, 2, 2, 3, 3, 4, 5, 5, 6, 6, 7, and 18. Count them all up and make sure that you're not missing any. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 scores there. To do my 5-number summary, I'm going to need the lowest, the Q1, Q2, Q3, and the highest. Now the lowest, I get straight from my scores there. The lowest score is a 1. The highest score is an 18. So there was 13 numbers there, remember? To find the middle, 13 plus 1 is 14, divided by 2 is 7. So 1, 2, 3, 4, 5, 6, 7. That 4 is going to be my Q2. So Q2 equals 4. Now there's 1, 2, 3, 4, 5, 6 numbers below that 4. So the middle of 6 numbers, 6 plus 1 is 7, divided by 2 is 3.5. So between the 3rd and the 4th, or in other words, 3 on either side. That will be the Q1. Now we would average them. 2 plus 2 divided by 2 is still 2. And then we do the same thing for the upper end. There's 6 scores, so that's going to be between the 3rd and the 4th. So 6 plus 6 divided by 2 is 6. I can find my interquartile range. So that's the Q3 minus the Q1. The Q3 was 6 minus the Q1, which is 2, and that equals an interquartile range of 4. Now, I'm not finished because I was asked to find the 5-number summary, done, the interquartile range, done, but I need to find out whether or not any outliers exist. So the outliers, looking at our scores, the lower end, they all seem pretty close together. 1, 1, 2, 2, 3, 3. Unlikely that we're going to have an outlier down there. But at the higher end, we've got 7, 6, 6, 7, and then a big gap to 18. So just by looking at it, we'd be pretty sure that that 18 is going to be an outlier, but we have to be able to show it with our formulas. I'm going to test both formulas just for practice. So the first formula was Q1 minus 1.5 times the interquartile range. Okay, so we sub in the things that we found over here. Q1 was 2 minus 1.5 times my interquartile range, which was 4. Okay, we calculate that, and that equals -4. That means that any score below -4 is going to be an outlier on the lower side. Now, I definitely don't have any scores that are that low, so we move on to the next one. The other formula was Q3 plus 1.5 times the interquartile range. Sub into that. Q3 was 6 plus 1.5 times 4. This time that equals 12. So anything above a 12 is going to be an outlier, and I do have my 18, which is above 12. So I can write myself a little conclusion. Therefore, 18 is an outlier. And it's not just by guessing, I have shown with my calculation that it is an outlier. Okay, so you need to work on exercise 4C, please.